Hello. So here we have a problem just computing a derivative, and our goal here is to use the product rule. So strictly speaking with this problem, right, because they're both polynomials, we could expand this out fully and then it would just be the polynomial rule or the power rule the whole way through. But rather than do that, and sort of it's up in the air as to which one you think might be sort of less work, but instead of doing that, I'm going to go with the product rule. So remember, the product rule says that if we have some f of x, g of x, and we want the derivative of both of these things, then that's going to be the first times the derivative of the second plus the second times the derivative of the first. But the nice thing is that, you know, this is multiplication and addition. So really, it doesn't matter which order you do this in because they're all commutative. So really, it's one of them times the derivative of the other plus, and then switch, right? The other times the derivative of the one. So I'm going to do that here. So in particular, with this f, so I'm going to get f prime of x equals. So I'm going to do sort of this form, but again, either way would be fine. So I have my first, right, this x squared minus 1 times, and I'm just going to write this out for the sake of sort of making it clear what's happening, the derivative of the second thing, so that's x cubed minus x squared plus x minus 3 plus, and then that second thing, so x cubed minus x squared plus x minus 3 times the derivative of the first thing, which is that x squared minus 1. Okay. So just go right through, right? So this thing stays as is. So this is x squared minus 1. Here I'm going to have, so remember, for polynomial, we bring the power down and subtract 1. So I'm going to get 3x squared minus 2x to the 1, right? Bringing that 2 and subtracting 1, plus, so this is a 1, I'm going to bring it down, and which does nothing, and then subtract 1, so I'm going to get 1 times x to the 0, or just 1. And really, this is 3x to the 0. If I brought the 0 down and subtracted 1, I'd just get, this whole thing gets killed off, right? So constants, the derivative of a constant is 0. So then I have x cubed minus x squared plus x minus 3. And taking the derivative of this, well, that's going to be 2x, right? Bring down the 2. And minus 1. The 1 goes away, right? Because it's a constant. And that's it. Now I could sort of multiply all this out and combine like terms and stuff, but there's no reason for me to do that here, right? So without some sort of motivation to do it, I'm just going to leave it as is, right? Like if this had like a follow-up where I had to like factor the result, or if I had to solve the result for a particular value or something, maybe then I would do that as, you know, part of trying to solve a polynomial. But all I wanted was the derivative. Here we go. So that's that. Hello. So in this problem, we want to use the product rule to take the derivative of f. Now, to be clear, this problem has a log in it, so I'm going to sort of go with the premise that you've already seen the rules for log. If you haven't, then obviously we wouldn't ask this question. But you know, depending on whether you're watching this for the first time or watching this part of a review, you may or may not have seen it. So just know, sort of, to be clear, sort of you would have to have seen the rule for log to know how to take a derivative of log. So if there's sort of if you haven't seen it yet, then you don't have to worry about having like a question like this yet. Nonetheless, I'm going to go through the same process. You can see the process, the product rule part. Okay. All right. So again, sort of in general, if we want to take the derivative of some f of x, g of x, that is going to be f prime of x, right? First times derivative, or the second times the derivative of the first, plus f of x, g prime of x. And again, nice thing about product rule, right? And I think even the last time I did this, I flipped those. But that's the point, right? Is that I can write these in any order, and I can flip them around if I want. The whole point here is that I just need sort of both combinations, right? One of them has an f prime, the other one has a g prime, and the other function in each case isn't having a derivative. Okay, so I have my f. So in my case, right, my f has one function, which is x, and the other function is 2/5 log base 7 of x. X to the 2/5 log base 7 of x. Okay, so f prime. So take, I guess, the derivative of the first. Well, that's easy enough. That's just 1, right? So the derivative of x is just 1 times the second, x to the 2/5 minus log base 7 of x plus, and now I want the f, so I just have, right, I just want that first function times the derivative of the second. So now I'm taking the derivative of x to the 2/5 minus log base 7 of x. So log x to the 2/5, that's going to be 2/5 x to the minus 3/5 minus, right? So that brought it down and subtracted 1, which got me negative 3/5 minus. So then I'm going to have 1 over natural log of the base, so natural log of 7 times x times the inside. So to be clear, maybe I'll make a notation of this since I sort of did it all in one go here. This is the derivative of x to the 2/5 minus log base 7 of x. And this was the derivative of just x. Okay? So that is that.